Hello. Okay, we are in 5th grade. We're on page 374, and we're doing investigation 7 called the coordinate plane, which I love because it seems to me like a game or like a puzzle. They kind of reminds me of connect the dots, so I really love this kind. I love this lesson. So we're going to start off with reading page 374 and learning some of the terms so that later on in later lessons, when I say a certain term, you'll know exactly what that means, okay? So we're going to start off and it says, by drawing two number lines perpendicular to each other and by extending the unit marks, we can create a grid called a coordinate plane. You see, we're drawing two number lines, one number line, two number line. And by the unit marks, 1, 2, 3, 4, and extend them as much as you want to, you can create a grid, and this is called the coordinate plane. Okay? So I see that coordinate plane in our book has some ordered pairs. So I'm going to go back down to the next paragraph and continue reading. The point at which the number lines intersect is called the origin. This point where the perpendicular lines intersect, right where it starts, because origin's like the beginning or the start of something, the origin, that's exactly where it begins. And it begins with the number 0 because it comes from 0 to 12 here, 0 to 12 here, 0 to 12 here, and 0 to 12 here. Okay? So the point at which the number lines intersect is called the origin. The horizontal number line is called the x-axis. Do you see this little x right here? This horizontal line, think of horizon when you look at the sun setting or rising and it's on the horizon and it's flat and you can see the sun either coming up or going down. That's the horizontal line and that is the x-axis. The vertical line, like you have a vertical jump when you jump up and down, is called the y-axis. Always, always, never changes. X-axis is always flat, y-axis is always up and down. Okay? We graph a point by marking a dot at the location of the point. We can name the location of any point on this coordinate plane with two numbers. The numbers that tell the location of a point are called the coordinates of a point. So two numbers name a point. The coordinates of a point are written as an ordered pair. Excuse me. The coordinates, where are we? The coordinates of a point are written as an ordered pair of the numbers in parentheses. For example, 3, parentheses, 3 and -2. That is an ordered pair. The first number in any ordered pair, the first number is always the x-axis. The x-axis is right here. So if you ever have an ordered pair and the first number, that first number is always going to be on the x-axis first. The second number is on the y-axis. First number is x-axis and the second number is always on the y-axis. So it's the horizontal direction and the distance from the origin. The first number is x-axis and the second number is the y-axis. So the first number is the x-coordinate. It shows the horizontal direction and distance from the origin. The second number, the y-coordinate, shows the vertical direction and distance from the origin. The sign of the coordinate shows the direction. Positive coordinates, positive numbers, go to the right or up. Negative numbers go to the left or down. See that? See how there's positive numbers on this side and up, but then it turns to negative numbers down and to the left. Okay? That's always going to stay the same. So going to the next page, 375. To graph 3, -2, we begin at the origin, right? Remember in the middle where they connect, and it's 0. So we begin at the origin and move 3 units to the right, because look here, along the x-axis, because our first number is always x-axis and our first number is positive, so we wouldn't move -3 because it's not a -3. We're going to move 3, positive 3 spaces. So 1, 2, 3, that's our x, but then our second number is -2, our y-axis. So this is our y-axis and it's not a positive 2, so we're not moving up 2 to this positive number. It's a -2. So we have moved over 3, but now it's telling us to move down where the negative numbers are, 2. So we've already moved positive 3. Now we're going to move 1, 2, negative 2. So this is where it meets. We have positive 3, negative 2, and we meet in the middle. And that is where our point is. Okay? 3, negative 2. That is our coordinate. So I think it tells us that on our thing, but this is how it goes. 3, negative 2. And that is our point. Okay? Easy peasy? From there, we move down. On the previous coordinate page, we've graphed 3 additional points and identified their coordinates. If you look over to the left again on page 374, it's marked negative 3, 2. So x-axis, right, negative 3, 2. And x-axis is always first. So here's our x. So negative 3. It's not positive 3, but 1, 2, negative 3. And then the next number is 2. So not negative 2 down, but positive 2, because if we're going up. So 1, 2, 3 negative, 1, 2 positive, and they meet in the middle. See that? And that's the other point. So this point is negative 3, 2. So it has a couple more there. If you want to look at that, you can pause it before we go on. And then we're going to continue to the next part. It says on page 375, it says refer to the coordinate plane below to answer problems 1 through 6. So number 1 says, what are the coordinates of point A? So we have to write our numbered pair, our 2 numbers, that tell us where this point A lies on this coordinate plane. So I know, what are the coordinates of A? Well, it's going to look like this, parentheses, parentheses, and 2 numbers. I know this one is the x and this one is the y-axis. So when I go to point A, how, from our origin, how far did I go before I had to stop? So from our origin, I went 1, 2, 3. I didn't go 4 because there's my dot right there. I have to line it up. But then that's only my x-axis. So I know the coordinates of point A. I know the x-axis is 3. So now, did I go down negative numbers or did I go up positive numbers to get to my A? Well, it looks like I went up. And the numbers up on the y-axis are all positive. So I've gone over 3 and up 1, and they've met in the middle. So I only went up 1, so my coordinates of A are 3, 1. See that? Let's try number 2. Which point has the coordinates negative 1, 3? So we don't know. Let's see. We don't know which one. So it says negative 1 and 3. So I know my first number is always x-axis, and my second number is always y-axis. So where is negative 1? This is my x-axis. Where do you think negative 1 is? Is this negative 1? Nope, that's positive 1. So here's my negative 1. So that's my x-axis. Now I need to go to my y-axis, which is up and down. Here's negative 1, and what is it telling me to go? It's telling me to go positive 3 units. This little square is a unit. So 3. So I already have negative 1, and now I'm going to go 1, 2, 3 units. Well, look at there. There we go. Negative 1, 3 looks like it's coordinate C. Do you see that? Negative 1, 3 is coordinate C because I went negative 1 and I went up 3. Okay, what's our third problem? What are the coordinates of point E? Well, here's point E. So let's see, I know x-axis goes first. So where are we on the x-axis? Well, we're to the left, so I know it's a negative number first. So E, comma, parentheses, there's my x-axis, and that's my y-axis. So how far did I go on the x-axis from the origin? 1, 2, 3. I have to stop because I didn't go 4. It's not over here. It's not over here. I went to negative 3 and I stopped. How far did I go down? And the down numbers on the x-axis are negative also. So from my first y-axis number, it looks like I went negative 3. Negative 3 is my x-axis. Now what's my number? Looks like negative 1. It went down 1, went over 3 and down 1. But it's a negative 1. See that? What are the coordinates of point E? -3, -1. -3, comma, -1, parentheses. That is the ordered pair, the coordinates of point E. So what's number 4? Number 4 says, which point has the coordinates 1, -3? Which coordinates have this ordered pair? What is this? Let's see. Well, I know this is the x-axis because it always comes first, and this is the y-axis. So we start with x first. Is it a -1 or a +1? Well, it's +1. So this is my x-axis, -1. Now we have a -3 on our y-axis. So we're going down where my negative numbers are, -3 units. So 1, 2, 3. Oh, there we go. 1, and I went down 3. That is point G. So which point has the coordinates 1, -3? Point G. How about number 5? Number 5 says, what are the coordinates of point D? Well, here's my point D. So let's see. I know the first one has to start with the x-axis, right? Parentheses, comma, parentheses, x-axis, y-axis, okay? You do not have to write this. This is just to help you during this investigation so you can remember that in your brain for later, okay? So D, what is the number that starts with on my y-axis? Well, I'm not over here, so it's not a positive number. I'm over here, which is a negative part of the number line. So D, I went over 1, 2, 3, because it lines up. So I went -3. And then where did I go? I went up. And the up numbers are positive. So I went up how many units? 1. 1. There you go. What are the coordinates of point D? -3, 1. What's number 6? Which point has the coordinates 3, -1? Let's see, which points has the coordinates 3 and -1? Well, let's see. Let's go to my x-axis. 1, 2, 3 units, and then -1 on my on my y-axis. -1 down. What looks like point H is 3, -1. Okay? H. Get that? Easy peasy. If you want to pause it and rewind it and see how we did that again, feel free to. Okay? We're going to go on to the next one. I'm going to continue reading on 375. Maybe I'll get a new sheet to help us out. Okay? Okay. The coordinate plane is useful in many fields of mathematics, including algebra and geometry. In the next section of this investigation, we will designate points on the plane as vertices of rectangles. Vertices of rectangles. We will then calculate the perimeter and the area of each rectangle. Remember what a vertex is? A vertex and vertices. So vertex is 1, right? Where 2 lines meet. Vertices is more than 1. Do you see where this line meets? And this line meets? And this line meets? And this line meets? So there are 4 vertices in this rectangle shape. So we're going to make a rectangle on a coordinate plane and see how many units are within it and how many units are around the perimeter of it, okay? So I'm turning to page 376, and we're going to, I think I might have written this other one down. Let's see. Nope, we'll just do it together. Okay, so suppose that the vertices of a rectangle are located at 3, 2, 1, 2, 3, 1, 2, 3, 2, and -1, 2, -1, 2. Those coordinates are -1, 2, and -1, -1. X-axis first. -1, -1. Okay, -1, -1. Coordinate points. And 3, -1. So 1, 2, 3, -1. Okay. 1, 2, 3, and -1. These are our points. So suppose we are told that the vertices of a rectangle are located at these points. We graph the points and then draw segments between the points to draw the rectangle. So you see we have a point here, We have a line here that connects these. We connect these lines and we connect these, and now we have a rectangle. We see that the rectangle is how many units long? Let's see how many squares. 1, 2, 3, 4. 4 units long. And how many units wide? 1, 2, 3 units wide. You see these units? 1, 2, 3, and 1, 2, 3, 4. Okay? Adding the lengths of the 4 sides, we find that the perimeter is how many? Well, there's 4 here, 4 here, 3 here, and 3 on this side, right? So what is the perimeter of this rectangle? How many units do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the perimeter of this rectangle is 14 units. So these little squares are units. So we say 14 units. To find the area, we can count the unit squares within the rectangle. There are 3 rows, right? 1, 2, 3 rows of 4 squares. 3 rows of 1, 2, 3, 4 squares. So the area of the rectangle is 3 times 4. 4 squares here, 3 squares here. 4 times 3 is 12. So we say the area is 12 square units, just like we do without a coordinate plane. Square units. Okay? That was easy. So for problems 7 through 9, use activity sheets 10 through 12. Okay, we can do that. So number 7. Okay. Is it asking us to do a separate one? I think it is. So we'll get a new one. Yes, let's get a new one. Okay, it is asking us, number 7. The vertices of a rectangle are located at -2, -1. Okay, so let's go ahead and graph this. It says, for number 8, it says graph the rectangle, and what do we call this special type of rectangle? Okay, so the vertices of a rectangle are located at, our first coordinate point is -2, -1. I know that the first number is x-axis and the second number is y-axis. So x-axis, this is a -2, so I know I'm going to go to the left, not the right, because the right is positive numbers. So -2, 1, 2, and then the -1 is our y-axis, and I'm not going to go up because these are all positive numbers. I'm going to go down, -1. So I went over 2, and I'm going to go down 1, right there. Okay? And then it says the next coordinate order number is 2, -1. So let's put our order number, -2, -1. And then we're going to go to 2 and -1. Okay? X, Y. 2, 1, 2, because it's positive. And then -1. So I'm going to go down to -1 since it's not a positive number. And this one is 2, -1. Our next coordinate point is 2, 3. 2, 3. Our next ordered pair is 1, 2, because it's positive. And then 1, 2, 3, because it's positive. Right there. 2, 3. What's our last one? -2, +3. So -2, x, y. So x is first. -2, so not over here. This is positive. But -2, and then how many do we go positive up? 1, 2, 3. So what do we have? We have connecting these, connecting this, connecting this, and connecting this. And this looks like a perfect square. So you should be able to tell me what special type of rectangle this is. I might have just went away. So what does B say? So we just did A, we graphed the rectangle. Now it says B, it says what is the perimeter of this rectangle? The perimeter. We just did it on our last example. So our perimeter is how many units of squares around the entire shape. But remember the last one, we didn't count this one because this didn't have any sides to the actual line. So we only count the squares, the units that have a side directly to the shape. So we have 1, 2, 3, 4. Oh, and we have 1, 2, 3, 4. So that common sense says if it's 4 here and 4 here, then it's also going to be 4 here and 4 here. 1, 2, 3, 4. So what's the perimeter? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 4 times 4 is 16. So the perimeter is 16 what? Units. 16 little squares. Okay? What is the next one? C says, what's the area of the rectangle? Okay. The area of the rectangle, well, there's 4 sides here. The area, so there's 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, and 1, 2, 3, 4. So 4 squares, right? There's 4 rows times 4 in each row. 4 times 4 is what? 16. There's 16 square units. Units. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. How about, looks like we need another one. The vertices of a rectangle are located at, I wonder if we can use the same one, -4, 2, okay, 0, 2, nope, it falls in. Let's get an extra one. Okay, so for 8, now we're number 8. The vertices of a rectangle are located at. So pause the video and see if you can graph this rectangle with these ordered pairs of number 8. It looks like the ordered pairs are -4, 2, 0, 2, 0, 0, and -4, 0. So pause the video, see if you can graph this by yourself, and then come back on, and I'm going to do it right now, and see if your coordinates match up with mine, okay? We'll see how far along you are, and see if you need to rewind it, and see if we need to go over anything again, okay? All right, so we're going to start with, we know the first number is x, and the second number is y. X-axis, y-axis. So we'll start with -4, 2. So x is -4. We start on our x-axis, and we know it's not +4, so it's not going to be that one. It's going to start at -4. -4, 2. Do I go down 2? No, because that would be -2. So -4, 2. 1, 2. Done. -4, 2. Okay. Then it says 0, 2. Well, I know 0 is x. The first number is always x. So here's 0. Bam, right there. 0 and then +2. 0, 1, 2. Right there. Didn't even have to go on the x-axis really a lot. Just put the 0 at the origin. What's the next one? 0, 0. Well, there's 0 at the x-axis, and there's 0 at the y-axis. So there you go. That's your point. 0, 0. We have -4, 0. So we start with our x, and then our y. So x, on our x-axis, we need to find a -4. 1, 2, 3, 4, and then 0. Well, we're already here to 0, so there's our point. Tricky, tricky. Does it want us to connect our thing? Yeah, I think it does. So we'll connect our lines, connect, connect, connect. And it's asking us to graph the triangle. Notice that one vertex is located at 0, 0. What is the name for this point on the coordinate plane? Remember? What was this point, the point where everything started from? Remember, it was called the origin. Okay, good job if you got that. Letter B says, what is the perimeter of the rectangle? Well, let's see, I have 1, 2 here, I have 1, 2 here, and I have 1, 2, 3, 4 here, and I have 1, 2, 3, 4 here. I have 4 here, 2 here, 2 here, and 4 here. 4, 8, 9, 10, 11, 12. See how we did that? We did not count this square. We did not count this square. We did not count that square or unit or this one because there is no sides that are up against this shape. It's only a vertex that's connecting, and vertices are not counted as a unit when it's the perimeter of a shape. on a coordinate plane, okay? It's just the sides connecting. So we only have 4 of the sides that are actually connecting, okay? So what do we say? 4, 8, 9, 10, 11, 12? So our perimeter looks to be 12 units. And our area, letter C says, what is the area of the rectangle? Well, the area is the amount of units inside the shape. So it looks like 1, 2, 3, 4, 5, 6, 7, 8, or 4 times 2. Area is 8 square units because it's squared, remember? All right, how about number 9? It looks like you might be able to do number 9 on your own, okay? So you should probably print out a whole bunch of these if we're gonna do it, because we're gonna do the next activity and it'll probably take more than one sheet. Okay, but for now, we're just gonna stop there and we're gonna come back to the activity drawing on the coordinate plane. Okay, but that's it for now, and just check out the next video. Starts at number 10. Okay, bye.